Okay, so we're going to start with our bell work like always. So the first part of this problem should be pretty easy, right? Because we have, so all it says is multiply the exponentials. So if I have two things that have the same basis, they're both 2's here. If I multiply them, then I add the exponents. So this is going to be 2 to the 5th power, right? Because if I have like x squared times x to the 3rd power, you add the exponents because both of the bases are x. So this is x to the 5th power. So same thing here. The only warning I do want to remind everyone, you do not multiply the bases. So this is not 2 times 2 gives me 4 to the 5th power. So just a warning there. So the base is not affected. Okay, let's take a look at this second part here. This part's a bit tricky, but I want us to understand that we've been learning logs, and logs just help us find exponents. So if you take the log of a base and you have a value, you get the exponent of this base. So this is what I mean. Logs give me exponents of some base. So like with this problem here, my base is 2. Okay, I'm going to write 2 here. Now, some exponent for this 2 gives me 4. Well, that exponent is 2, right? 2 squared gives me 4. Now, when I look at this section here, this log says I have a base of 2, and there is some power that makes this 2 an 8. Well, we've learned this multiple times. 2 to the 3rd power gives you 8. So logs give me exponents, and these are the exponents. Let me grab a highlighter here to show you guys. So what I mean is this 2 here is what I get when I take my log. So this log here is a 2. Whereas this 3 here is the value when I take this log. So this value here is 3. And there's a plus sign in between them, so I need a plus sign in between here. Well, if I look down here, what it results to is 2 plus 3. 2 plus 3 is 5. Now, this number here that we just resulted in is not just any value. This value here is the exponent, right? This 2 was the exponent of this one. This was the exponent of this one. Well, this is the exponent of this 2. So let's try to fill in this blank. So this is 2 to the 5th power. Well, what is 2 to the 5th power? Well, that's 32. So that's what goes in the blank. Now, that was a lot of work, but I really want us to understand this equation here and a better way of finding what was supposed to be in that blank space. So I want us to take a closer look at the number inside the log. So if we take a closer look at this log, I have a 4 here and an 8 here, and it resulted to a 32. Now, all the bases are the same, so the base is good. So how can I make 4 and 8 32? Well, when I multiply 4 and 8, I get 32. So it turns out when I have 2 logs of the same base and I'm adding them, I can actually condense it by multiplying the numbers inside. So I just wrote all of this and simplified it to 1 log by multiplying the inside, all because the bases are the same and there's a plus sign in between them. This is one of the properties that we are going to be learning today, and you just got a glimpse of it. So we're going to be learning 3 log properties. So let's go ahead and move on to our next slide to learn the 3. All right, so let's take a look at all the 3 properties for logs. Now, we just saw the first one in the first slide here in the bell work. So let's write that down. So for logs, if you have multiplication on the inside of the logs, then we can expand it by using addition. So we can break up the x and y with addition. So each log will get a component in the parentheses. So this one was y. Okay, so for division, that's the opposite. So for division, instead of addition, we would expand it using subtraction. So I'm going to write this as log bx minus log base y. you'll notice that it's always like the numerator is in front, whereas the denominator is after the minus sign. Okay. This one here, ignore the weird red typo squiggle that just happened because I wasn't paying attention. So with this one here is asking what is the rule for if you have a base to an exponent. So this one's like, how do you deal with logs that have exponents inside? Well, turns out exponents, what happens is that the exponents get put in the front of the log, okay? So in this case, you would have n in the front, or let me grab my black pen, n log base x. So exponents for logs, when you expand them, actually are in the front of the log. So exponents are in the front of a log. Okay, and I think that's it. Those are the three properties, and we're going to be using them today to help expand and condense log, and you'll see what I mean here in a sec. All right, let's start out with our first problem, and in these four small problems here, I'm going to be expanding the expression. So like the first one here, I have log base 5, and inside here I have a 4 and an x. So when numbers are written next to each other, that implies multiplication. So I can expand this by using the first property that we learned. Actually, you know what? I'll write all the properties here to the side. Just so that we can visually see that. So the first property is if I have multiplication, a base inside, say x and y, then I can expand it using addition. So this is log base y. And so here I go. So this 4 here gets expanded. I have log base 5, and then this would be a 4 inside here, plus log base 5, and then an x in this one. You don't necessarily need these parentheses, but it doesn't hurt to have them. So in this case, what you do to make sure that you're done expanding is that inside the parentheses, you can only have one number or one variable. That number can't have an exponent, and it can't show any multiplication or division. So notice that this 4 is alone inside the parentheses, so this is done. This is done expanding. This here just has an x, so this is done expanding as well. So I know I am finished when I just have one number or one variable inside. So I'm going to box in that for my answer. Okay, let's move on to the next one here. I'm going to go ahead and list the rest of the properties here. So the other one was division. So if I have x divided by y, then I use subtraction. And then the last one but not least was if you have an exponent, so log base x to a power. Remember that power gets to be put in the front of the log, and then the x would be by itself, or the base would be by itself back in the log. Okay, so those are the three properties, and let's take a look at B now. So for B, one thing I immediately see that is that there is a division here, right? Like I'm dividing 3y from 2x, but there's also multiplication here, like 3 times y, 2 times x. So what do I do first? Well, it doesn't really matter which one you do first, but it might be easier to start out with just the division part. So what I mean is, think of, if I had to deal with division, think of the numerator dividing the denominator. So with division, I need to use subtraction to expand. So I have log base 6, 3y minus log base 6, 2x. So I start by just separating the numerator from the denominator. And then from there, I can just look inside of the log. This is a 3y, so I'm going to just separate this guy here. Okay, if I were to separate this guy, that would be log base 6, 3 plus log base 6y, because for multiplication, I expand using addition. There is a minus sign in between them, so I'm going to bring down that minus sign. But I want us to be really careful here. So this log has a minus sign in front of it. So that means if I expand this guy, I have to make sure that I distribute this negative to everything that is expanded. So just to be very safe, I am going to put parentheses here, and then whatever this ends up resulting in, I have to distribute that negative. So here I go. If I expand log base 6 2x, that's going to be log base 6 2 plus log base 6x. And then I can see, oh, I have to distribute this negative to both logs. Because if you forget to put those parentheses, you might also forget to distribute that negative sign. So I'm just giving you some tips on how you can kind of keep yourself in check. But if you skip this step and you still remember to distribute the negative, then that's fine. Okay, so I'm going to bring down everything because I haven't distribute that negative. So I'm going to go ahead and bring the first two logs down because these two are simplified. So I'm just bringing them down. I have to distribute that negative. So that's negative log 6 2 plus log 6x. And I think that's it. So I'm going to, grab my highlighter and box this in. Okay. Now let's take a look at problem or part C. So for part C, I notice immediately that there's an exponent outside here. Now it's very tempting to go straight to the third property and put this exponent in the front of log. Okay, and you can do that, but a better thing to do here is to first take the 3, the exponent, and distribute the 3 in for the 7 and the p. Okay, because that's the exponent rules that we've learned back in first semester. So if you have an exponent outside the parentheses, you have to distribute it to everything inside the parentheses. So I actually have log base 7 to the third power and p to the third power. And then from there, I notice that inside, it's this 7 to the third power times p to the third power. So this is implying multiplication. Well, how do I separate multiplication? Well, I have to use the addition to expand it. So I have log 7 to the third plus log p to the third. Oh, by the way, I didn't mention this a moment ago, but notice that this one doesn't have a base written, so by default the base is 10. Now, you don't necessarily have to write the base when you're expanding or condensing because we don't really care much about the base. The only time we really care about the base is when we're solving for logs or when we have to rearrange things. But we're just expanding, so we can all assume that if there's not a log written, then they're all 10s. So I just kind of want to bring that to light. You're more than welcome to write the 10 there if it bothers you that there isn't a base written. Okay, now inside here, we know we're not done yet because there is an exponent stuck to the number. So we have to take care of that exponent. And remember, the way we take care of exponents is we kick them to the front of the log. So I'm going to take both of these exponents and put them in the front. So that would make 3 log, and then just 7 on the, and then p on the inside. And so I'm going to now box my answer in, and that's it. Okay, so now we're going to take a look at part D. So part D has a natural log, okay? And I didn't give you any rules about or properties about natural logs because natural logs are a type of log. So they're going to be using the same type of rules that we have used for the logs. So natural logs, or ln, use the same properties as logs. Okay. In that case, let's take a closer look on how I can expand this, or if I can even expand it. Well, looking at this inside here, I have a square root inside. Okay, so how do I remove this square root? Well, first I have to think about, okay, can I make the square root into an exponent? And yes, we can. We learned how to change roots to exponents. So let me see if I can draw out your memory a little bit. So first, to try to change things to exponent, I need to know what is the power on this x and what is the root on this, square root. So square roots by default, the root is 2, right? So I can write a 2 here, and this x is to the first power. So if you remember a few units a while ago, if you have a square root, let's say x, and you have it to some exponent and then a root n, you can write it as a fraction exponent. So remember that the exponent, the m in this case, goes in the numerator, whereas the root goes in the denominator. So you always divide by your root. So if I were to change this square root of x into an exponent, well, that would be the natural log of x 1 over 2. Okay, because, 2 is my root, so that goes in the denominator. 1 is my exponent, so that goes in the numerator. And so I could easily change that to an exponent. So that's a handy formula, or handy formula to rearrange roots to exponents. Because once I see that there is an exponent, then I put this exponent in the front to try to expand it further. So in this case here, I have, 1/2 natural log of x. And the x is by itself inside the parentheses, so I know I'm done. Okay, so in the previous slide, we were learning about how to expand a log. So taking all the stuff in the inside of the parentheses and expanding it using the properties that we learned. But now we're going to do the opposite. We're going to have an expression where we have several logs, and how can we condense it so that we only have one single log with everything written inside that parentheses. So I'm going to show you how you can do that, but we're still going to be using those 3 properties to help us out. So in the end, your answer should have one log and all the properties inside that log that was used. So in this case, like the first problem here, notice that there are 2 logs, so that's too many. So we have to somehow take these 2 logs and bring them together to make one log. Well, if we take a closer look, what I notice is that there is a plus sign in between them. So if I want to join them together, I can use that first property, which says that addition pairs with multiplication. So I can take this x here and multiply it with this x minus 7. So let's write out what that would look like. That would be like log base 2 x times x minus 7 in the log. Well, when I look at this problem here, I notice that inside here I can do a little more, right? I have x times the stuff in parentheses, so I can distribute. So I'm going to distribute this x. That would make it log base 2. X times x is x squared. X times negative 7 is negative 7x. And it looks like I am done because I have only one log out here and all the stuff is contained inside this one parentheses. So I'm going to box that in. That is my answer. All right, let's try out B. So for B, you'll notice that there is 3 logs to deal with now. So instead of dealing with all the logs all at once, I recommend take 2 of them first and try to join or condense them first and then bring in the other logs. So I'm going to first just pay attention to these 2. So these 2 are joined together with a plus sign, so I know I need to multiply the that's not a highlighter. Multiply the insides together. Here, so that's what I'm going to do here. Let me grab a pen. So I have log, and both of them are base 10, so I need a 10. And I notice with this one here, I have an x, so I'm going to bring that down. But with the second one here, I notice there's a 2 in front of this log. So if you remember previously, I said that the number outside the log represents the exponent. So if I pull this 2 back inside the log, this actually makes this y to the second power, or y squared. So what I like to do is just bring back the number in front as the exponent. So this is going to be x times y squared. Maybe I didn't need that much room, so let me move that parentheses there. So that's going to be xy squared on the inside of this first log. So that was this part right here. Now we're going to try to bring down the second log and see if we can combine it more, or condense it more. So I've brought it down, and so now notice that these two logs are joined together with a minus sign. So that means that I have to, if I want to condense them, I have to use division. So I'm going to write log base 10, and then I'm going to make this a division. So it looks like this is going to be in my numerator because it's log base 10 x minus xy squared minus this log, which has a z. So in the numerator, I have xy squared. In the denominator, I have z. And then I take one last look at it. There's just one log here, which is good. And then for the x, z, and y, they're all different variables, so I can't combine anymore. So this is it. This is my final answer. Okay, let's take a look at C next. C here, you'll notice, has a number in front of the natural log. And just as a reminder, natural logs work the same way as regular logs when it comes to the properties. So going back to what I said before, there is a number in front of the natural log, so that represents the exponent. So what I'm going to do is just bring that back into the natural log. So in other words, this 1/4 is the power for this x, whereas this 2 is the power for the y. So this means that I have the natural log of x to the 1/4 minus the natural log of y to the second power. And looking at this here, I have a minus sign joining this natural log. So that means that I can condense it using division. So I have x to the 1/4 and y squared in the bottom, and it looks like this is it because I can't join these two. They're different. They're different terms, or not like terms. And that's it. Now, some of you guys might be thinking, like, why didn't she change this x to the 1/4 to a root instead of writing it as a fraction exponent? Well, the reason why is you don't have to. Because if you were to write this in a root, it'd still be encapsulated inside the parentheses. So I don't have to do anything here because all the direction says is to condense the expression. So once you get everything inside one natural log or one log, you're good, okay? And you want to simplify the inside, but making it a root is not going to help us to simplify this any further. So that's it for C. So D is next. D has quite a bit of stuff going on. There's 4 logs this time. But how about we work inside of each parenthesis separately? So like with this one here, first thing I notice is that these 2 logs, there's a number in front of the logs, right? So that number is the exponent for this x. This is the exponent for this y. And because there's a minus sign in between, I know I'm dividing these two when I condense. So I'm going to try to do everything in one go to try to save some space here. Don't feel like you need to do it. You could do it step by step. So I know I have a log, and this one has a base of 10. I'm not going to write that, though. I don't need to. And there's a minus sign in between them, so I know I need division. But for the top one here, there is a 4 on the outside, so this is going to be x to the 4th power. So I need that in my top. So that one goes for this x. This 5 goes with this y, so I need y to the 5th power in the denominator. I'm going to do the same thing with the other side here. I'm going to bring down that plus sign first, though. And then this here, I notice that both of these logs are joined together with subtraction, so I know I need to divide to combine. So I have log base 10 with this one too, z, and then there is a exponent outside, right? So this is the 1/3, w to the 1/3, so this is w to the 1/3 in the denominator. Okay, so from here, I notice that these two logs are joined together with a plus sign. So that means I have to take this fraction and multiply them, because addition is to condense it. For addition, you need multiplication. So I have log x to the 4th over y to the 5th times z over w to the 1/3 power. So now when I multiply straight across, because in fractions you multiply straight across, I notice that they don't have none of these are like terms. So it looks like I'll just have to write them next to each other. They're going to buddy up, but nothing combines really. So I have log x to the 4th, z over y to the 5th, w to the 1/3, and I think that's all I can do. So now I have one log and the inside is simplified, so I'm good. And that's it, guys. We've just learned how to expand logs and condense them. So now try out page, which one is it? Page 3 of the packet 11. See if you can use some of the things that we've learned in this journal to help you out.